Welcome everyone. We are discussing binomial theorem. We have already discussed the theoretical part of binomial theorem. That is the basic concept. Today I will discuss some problems based on divisibility. Problem number 1. Prove that 2 to the power 3n minus 7n minus 1 is divisible by 49. n is a natural number. 3 to the power 3n minus 26n minus 1 is divisible by 676. So, they are exactly same. So, consider problem number 1. So, 2 to the power 3n minus 7n minus 1. Now, we can write it as 2 to the power 3 whole to the power n minus 7n minus 1 by rule of indices. Now, this is 8 to the power n minus 7n minus 1. Now, this one is 7. So, we expand 8 to the power n as 1 plus 7. So, this is 1 plus 7 whole to the power n minus 7n minus 1. So, why we are taking 1 plus 7? Look, it will be clear after one step. You always take first term as 1. Now, this is 1 to the power n, this is 1, then nc1, 1 to the power n minus 1, 7 to the power 1, nc2, 7 to the power 2, nc3, 7 to the power 3, and finally this one is 7 to the power n. This is expansion of 1 plus 7 whole to the power n. Now, minus 7n minus 1. Now, you know nc0 is 1, nc1 is n. If lower suffix is 1, it will be upper suffix n. So, if we expand it, 1 plus n into 7, nc2 7 square, nc3 7 cube, 7 to the power n minus 7n minus 1. We are writing only nc1 equals to n. Now 7n, 1 is cancelled, 7n, 7n is cancelled. So 7 square common, nc2, nc3 into 7, and lastly this one is 7 to the power n minus 2. Now, you know nc2, nc3, they are all integers. So, the thing within bracket is sum of integer. That is why it is integer. 49 into integer. Bracket thing is an integer because it is sum of integer. So now this one is 45 into integer. So this is our main aim, to express the expression in terms of multiple of 49. So 49 into integer, therefore 2 to the power 3n minus 7n minus 1 is divisible by 49. So, this is 7. So, try to express it as in terms of 7. Now, second problem, exactly same, 3 to the power 3n minus 26n minus 1. So, 3 to the power 3 power is n minus 26n minus 1. So this is 3 cube, that is 27. So look, this is our main m. This is 26. So 1 plus 26 whole to the power n minus 26 minus 1. Then expand it as earlier and complete it. You try to complete NC1. 26 to the power 1. 1 to the power anything is NC2. 26 square. Then 26 whole to the power n minus 26n minus 1. So exactly same that of earlier. So you complete it. So 26 square will be common and 26 square is 676. Now problem number 3. 3 to the power 2n plus 2 minus 8n minus 9 is divisible by 64. So this equals to 3 to the power 2 into n plus 1 minus 8n minus 9. So 3 squared to the power. So 9 to the power n plus 1 minus 8n minus 9. So this is 8, 1 plus 8. So this is our main m. So 1 plus 8 whole to the power n plus 1 minus 8n minus 9. As of earlier, here n is replaced by n plus 1. So 1 n plus 1 c1 8 to the power 1. Mind it, this is n plus 1. So n plus 1 c2 8 square. N plus 1 c3 8 cube. And finally dot 8 to the power n plus 1 minus 8n minus 9. Then expand the first term only. N plus 1 c1. So lower suffix is 1. So this is only n plus 1. N plus 1 c2 8 square. N plus 1 c3 8 cube. 8 to the power n plus 1 minus 8n minus 9. Now look, 1 plus 8, this is 9 and 8n. So 8n minus 9 is cancel out. So you get 8 square common. N plus 1 c2. 8 into n plus 1 c3. 8 to the power n minus 1. Now bracket thing is sum of integer. Because n plus 1 c2, n plus 1 c3, they are always integer. Integer multiplied by 8, then sum of integer is integer. So 64 into integer. So this is our main m. To express this as multiple of 64. Therefore, 3 to the power 2n plus 2 minus 8n minus 9 is divisible by 64. Divisible by 64. So, they are all of same type. You can solve this problem by using induction method also. Next. Now we consider two problems. Which one is greater? 1.1 whole to the power 10,000 or 1,000? 1.2 whole to the power 4,000 or 800? 1.1 whole to the power 10,000. So this is very nearer to 1. You can write it 1.01 whole to the power 10,000. Now expand it. 1 to the power anything is 1. 10,000 C1 into 0.1. 10,000 C2 0.1 whole square. And finally 0.1 whole to the power 10,000. Now if lower suffix is 1, then it will be upper suffix. This is 10,000 into 0.1 and make it unchanged. 10,000 C2 0.1 whole square plus 0.1 whole to the power 10,000. Now this is 10,000 into 0.1. So 1000 plus 1 is 1001 plus positive number. So this one is sum of positive number. So it may be small, but you get this one as positive. So we can say, so 1.1 whole to the power 10,000 greater than 1001. Therefore, it is obviously greater than 1000. Greater than 1000. So same technique, 1 plus something, then expand it and conclude. Now, problem number 2. Exactly same. Exactly same. So 1.2 whole to the power 4,000. So 1 plus 0.2 whole to the power 4,000. So 1 4,000 C1 0.2. 4,000 C2 0.2 whole square. And finally 0.2 whole to the power 4,000. That of earlier. Now this is 1 plus 4,000 into 0.2. That is 2 by 10 plus this one sum of positive number. So plus positive number. So this is 800 plus 1. So 801 plus positive number. So this is greater than 801. Obviously greater than 800. So therefore first one is greater. So exactly same that of earlier. So today through this class we have solved 3 problems of divisibility of numbers and 2 which one is greater. These are basic problems. But problems of divisibility. So this is important for competitive exam also. So you practice this type of problem from any standard book. Thank you for today.